Let's take a deep look into the graphical and mathematical representation of sinusoidal alternating current, or AC quantities, which are used to describe how voltage and current behave in an AC circuit over time. First, let's focus on the top diagram, which shows the instantaneous voltage. On the vertical axis, we have voltage, and on the horizontal axis, we have time. The wave drawn here is a smooth, curved line that repeats itself after a certain interval, known as the time period, labeled with a capital T. This curve is called a sine wave, and it is the most common way of representing alternating voltage in electrical systems. The equation shown is V of t equals Vm sine omega t, where V of t represents the voltage at any particular moment in time. The symbol Vm stands for the maximum or peak voltage, which is the highest value the voltage reaches in one cycle. The variable omega, written as a Greek letter W, is called the angular frequency and is measured in radians per second. It describes how fast the wave is oscillating. Now, angular frequency is related to the actual frequency, which is how many cycles happen per second, measured in hertz, using the formula omega equals 2 pi times f, where f is the frequency. So, putting this all together, the equation V of t equals Vm sine of 2 pi ft tells us the instantaneous voltage at any point in time for a given frequency and peak voltage. As time increases, the voltage rises smoothly from 0 to its peak positive value, then returns to 0, drops to a peak negative value, and finally comes back to 0, completing one full cycle. This behavior continues endlessly in a perfect sine wave. Now, let's look at the lower half of the image, which shows the same idea, but for instantaneous current. Again, current is shown on the vertical axis and time on the horizontal. The wave has the same sine shape, and it also repeats after the same time period t. The equation is I of t equals m sine omega t, where I of t is the instantaneous current, m is the maximum or peak current, and the other symbols mean the same as before. This means the current also varies with time in a smooth and predictable way, rising and falling in a wave-like pattern. At any given moment, the value of current can be found using this formula, just like voltage. Both voltage and current are examples of sinusoidal AC quantities, meaning they change direction and amplitude continuously over time. They are not constant like DC values. This is very important in real-life applications because our household electricity, the power in factories, and most electric power transmission systems use AC, not DC. Understanding these sine wave graphs and their mathematical equations is the foundation for learning more advanced topics like phase difference, impedance, power calculations, and how AC machines and devices operate. So,